Hi, so today we have this lead code medium and it's a linked list cycle 2. Let's read the description. It's given the head of a linked list, return the node where the cycle begins. Okay, if there is no cycle, return null. Okay, there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Okay, internally pause is used to denote the index of the node that tail's next pointer is connected to, zero indexed. Okay, it is -1 if there is no cycle. Note that pose is not passed as a parameter. Okay, so this is the linked list 320 -4. Pose is 1, so that means tail is connected to this um, one index element, that is 2. So in this case we will have to output tail connects to node index 1, so we will have to output this node 2. And let's look at another example. In this case we have a single node, so here we will have to output no cycle, that is we have to output null. So as we know that when we are talking about cycles, we typically use slow and fast pointers. So that is the algorithm we use to detect cycles in a linked list. So we will be using this technique in here as well. So let's start. So the basic idea of these pointers is, if you don't know, let me explain it to you first. So it's suppose we have a linked list that is like this. So we have a slow pointer that moves one by one. So slow will go from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9, but fast will go a 2 step at once. So it will start from 1, then it will go to 3, then it will go to 5, and then it will go to 7, then 9, and since there is a cycle, so it will go to, suppose cycle begins at 4, it goes to 4, then it goes to 6, then it goes to 8. And if you look here, they are at the same node now. So that is the main technique. But if there wasn't any cycle, so for fast will have been pointing to null here. So that's how it works. So slow will be had initially, and fast will also be had, and then we start. And if you look here, so fast starts pointing to null, and the next fast dot next starts pointing to null. So what we have to do is we have to check if fast exists and fast dot next exists. That means we still have some nodes that can be visited, reached from here. But if that's not the case, then there are no cycles and we have reached the end of the linked list, so we will have to return null. Otherwise what we have to do is we make slow equals to slow dot next, we move by 1, and fast equals to fast dot next, so we move by 2. And so now here's the thing, to detect the cycle, these slow and fast have to be at the same node. So we just know that slow and fast will at some point meet. So like in this case it was at 8, so found the intersection. So this was the intersection, and now this question asks us to return the node where the cycle begins, like we have to return 2. For that let's look at this example again. So in this case, suppose this distance is x, and then this is y, and then this is z. So suppose the distance traveled, instead of 4 we can make it 6, the point where it matched, or let's just do it like this. So this is Z. So in this case, x, our slope pointer has traveled. If you look here, our slope pointer has traveled. How much? It has traveled x plus y distance. So that will be x plus y. This goes to here, and the cycle begins at 4, so we can denote it like this. So this slope pointer has traveled x plus y to meet this distance, while our fast pointer has traveled x plus y plus z and plus y. So that is slope is x plus y, distance by slope pointer is x plus y, and distance by fast pointer is x plus y plus z plus y. Since it traveled from x plus y plus z, then back again to here and then plus y. So that will be x plus 2y plus z. Okay, and what we can do is we can use the time distance formula, that is time equals to distance divided by speed to like compare these two distances. Since we know the speed as well, speed of slope pointer equals to 1 and speed of fast pointer equals to 2, so we can equate them. So it will be like x plus y equal divided by 1 equals to x plus 2y plus z divided by 2. Okay, that's going to be 2x plus 2y equals to x plus 2y plus z. So this 2y takes out this 2y, and then this x goes on the left side and becomes minus x, and then we can subtract it from this 2x, so it will be x equals to z. Okay, so that means that the distance traveled from the beginning to the intersection point is equal to this distance, the distance it will take from intersection to this x. Points back to 4. So it says distance from start or head to cycle start equals to distance from intersection to cycle start. So for this, what we can do is we can like move one of our pointer to the head again. So let's move slow to head. We can also move fast, but I'm just taking slow. And then while they don't match, so while slow is not equals to fast, what we do is we move them one by one. Since it's the same distance at the same speed, so we move slow equals to slow dot next and fast equals to fast dot next. So now next time they intersect, it will be on this intersection point 4, since it's the same distance. So now when they intersect, that is slow equals to fast, it will come out of that while loop, and we can simply return either slow or fast because they are equal. Let's try to run it. Okay, it got accepted. Let's try to submit. Accepted. Yeah, right, that's all. So we used slow and fast pointer, slow fast pointers, and space complexity is going to be O of 1 since we are only using these variables and not storing the whole linked list again, so it will be of 1. And space complexity and time complexity is going to be O of n plus k since we will have to traverse the linked list of n plus k. So this will be the time complexity. So n is the leading term, so we can take n as well. So that's all for today. Thank you. Bye bye.